It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson.
Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, I have with me my lovely co-host, Andy Grabner. Andy, how are you doing today?
I'm good. I was trying to make faces to kind of get you off your spiel, but I guess I didn't succeed. Yeah,
I saw you.
Yeah, but you kept your cool.
Yeah, I kept my cool, and maybe it just also means you weren't being funny enough. I don't know.
Yeah, I guess so, right? And
you need to try better. You need to try better. You need to improve that comedy performance of yours.
All right.
See,
well, the thing is, I'm not getting paid for being like funny, right?
Yeah, because you'd be poor.
I know.
So would I, though. So would I. I'd make a lot of money in bad dad jokes, though.
Yeah.
But see, I'm not even going to try. See, so my favorite thing now, lately, between you and I, is when we start talking, and in the back of my head, I'm going to think of a segue, and it never happens. It doesn't come, Andy. So I was about to say, I don't know what to say.
That was funny. I always think of a segue because it was the first company I worked for that was related to performance. Segway software back then. Yeah. I think they already...
What was the name of that one? It was
Segway software.
Was this?
Segway.
But the instance, it wasn't like how it's like you had Mercury, you had Load Runner, Wind Runner, and all. Segway.
Oh, Silk Performer.
Silk
Performer was the tool. Or Silk Test, Silk Performer, and But you know what? I don't think our listeners like to keep listening
to us. Stroll down memory lane.
Exactly. From Andy to Mandi Walls.
I knew you were going to use that. I peppered him with that. At least I'll take a little credit.
I know. It was your idea. But now, Mandi, welcome to the show.
Hey, thanks, guys. It's nice to be here.
Thanks for not running away after listening to us for 3 or 4 minutes. Still there. Mandi, for those of the listeners that have never heard about you, you may want to introduce yourself, who you are, what you do, why you think you're on the show.
Yeah, so thanks for having me. I am Mandi Walls. I'm a DevOps Advocate at PagerDuty, and I'm a recovering systems administrator. That was my original role in technology, and then I spent a long time at Chef Software doing like automation and infrastructure as code and cool stuff like that in the DevOps world. And like most recently for PagerDuty, we've been working on like a series of talks about helping our customers deal with all the stuff that comes up when you put software into production and what happens and how to manage it and how to get better at it. So, yeah.
So isn't the solution just to not put any...
Don't put anything in production. Don't attach anything to the internet. Just don't. Right. That's
just run it all local. All local. That's it. Because it always works on my machine. So there was a really, I don't know if people are familiar with Tim and Eric, the comedy duo, who do this really weird stuff, but they had a fun early internet type of video, and the internet came on a CD-ROM, and you could shop for clothes on the CD-ROM, and then when you wanted to buy one, you would print it out and mail it in to the company. But that was like the internet. No, it was the internet. But anyway, to your point, if you keep it all turned off and you're self-contained, what's going to go wrong? Nothing.
No problems, nothing to talk about anymore. But fortunately, there are problems out there. But there are solutions to problems, or at least approaches how to make problems less painful, right? And the way we actually got to know each other, I think I've followed your work in the past, and I'm pretty sure I've actually seen you prior to the last time I saw you, which was like 4 weeks ago when we were both speaking at DevOps Days in Raleigh.
Yep.
And you were, I think, presenting in the morning, and your talk was Plan for Unplanned Work, Game Days with Chaos Engineering.
Yeah.
And that was really cool. Now, can you enlighten the listeners on what this all means? Because planning for unplanned work seems pretty cool, because it kind of sounds contradictory. That if you can plan for unplanned work, and then also the concept of game days with chaos engineering. We had people and guests in the past to talk about chaos engineering, but I would love to hear it from you. What's the big thing that people need to know about?
Yeah, awesome. So we refer to unplanned work as like obviously the opposite of planned work. So your planned work is like the sprints that you're working on, the things you're putting into your products, the features that you're developing sort of intentionally. And unplanned work is like all the weird stuff that happens when you put software into production and it like meets real users and they do strange things, or you get like whatever weird requests come in off the internet just because, and you're just not sure what's going to happen. And all the other stuff that can sort of break or wiggle around, be kind of weird in distributed environments. So thinking about unplanned work as your incidents and alerts and what happens when something goes wrong and like the system breaks in some way, and we kind of lump all that stuff together. And planning for that is part of the practice that we stress with our customers, in that to get good at responding to those weird things that happen, you got to practice, but like practicing for weird things requires more weird things to happen, and we don't want that. So we started leveraging more chaos engineering practice, which is sort of fault injection, intentionally putting weird things into the system in a way that we know they're going to happen, we know where they're going to go, so that we can test, hey, did our monitors work? Did our alerts go off appropriately? Did we page the right people when we poked the system in this way? Did all the stuff that we expected to happen? Or was there something weird and wonky that didn't do what we expected it to do? So we can improve our response, we can improve our monitors, we can improve the overall reliability of all these systems. So it all sort of hangs together in a bigger practice.
For me, this has a lot of parallels with, at least I assume, what firefighters do. Firefighters, I guess, they don't just wait for the next big fire and then, what do we do? Well, we haven't done this in 3 years, and then things fail, but they actually practice all the time, and obviously they don't put fires or they don't put houses on fire where people live in, like they don't do it in production, but they actually train and exercise. Now this brings me to
you say that, but like I grew up in a place with volunteer firefighters, so like you could actually like donate your house to the fire department and they would do a practice burn if you had a house or a property that was in disrepair. Like they would absolutely do that, whether it was a tax write-off or what donation or however that part of it worked. But like I have seen many practice fires because in a small community, we have nothing else to do. Yeah. So you kind of follow the fire department out. And like
with a 6-pack and the
right, you just take your lawn chairs and go watch a house burn. It's super weird, but definitely happens. And where I live now, the fire department uses the culvert across the street from me to practice with the tower, with the tower ladder. So they all roll up with the big fire truck and distract me for an afternoon with practicing using the tower ladder, which is fascinating. So everybody has to practice. And you're right, like our incident response process and a lot of these other things are really built off of emergency response sort of in the real world, quote unquote. So.
And do you think we should start a business with donate your production environment for people that want to?
There you go. That'd be hysterical.
Yeah.
We have this whole thing we're going to sunset. Yeah.
Exactly. Or like, here's my AWS keys. Do whatever you want for the next hours. And then it's like,
you'd be amazed how many Bitcoin miners you can get loaded up in an hour. But yeah.
It's interesting on that idea, Andy. I remember, so when I first met Mark Tomlinson, and this relates to this idea very specifically, he was working down at the Microsoft labs in one of the Carolinas, wherever that one is. And they invited us down to load up our system and do a performance test in a large lab with their experts looking at everything. But it's almost as if you could do chaos testing as a service. You spin up an incident of your thing. There'll be a strike team of chaos engineers who have all these, lots of chaos experience, will come in and just really, you get the team in, you guys ready, and then you just chaos the crap out of it and make it a fun exercise for the whole team. That could be a side business there.
So the chaos for hire.
Yeah.
It's like a hitman that
you
can
call it Captain Chaos. That was Dom DeLuise in the Cannonball Run. I think he was. But anyway, you have some kind of creative chaos thing. Anyway, that's sidetracked. But I mean, to that point, that would be real. I think people would have a heck of a lot of fun with that. Yeah. So anyone out there is looking for a new entrepreneurial
there you go, free ideas.
Free ideas.
Hey, Mandy, one question that always comes up when we talk about chaos engineering, do you really enforce chaos in production, or do you do it in a pre-production environment? What's your take on it?
You can do it anywhere, really. And, for certain kinds of what we call chaos practices, or the kind of experiments that you can do with a chaos framework, you really want to be running at least some of them is shift that left, right? Things like how does this library respond when the backend doesn't respond within the tolerance? What does it do? And doing that sort of testing super early in the development cycle, so you're not putting something into production that's way out of your tolerance and then discovering that when you inject your fault there, that there's a big problem. So certain kinds of tests work real well, pushing them into the dev cycle really early so that they're part of your initial cycle of tests. So you can say to the developer, hey, this is outside of our operational parameters. Take another look at this component. And then for once you get into a larger environment, if you have, not everyone does, have a real rigorously maintained staging environment, you can absolutely be doing things there before it gets to production. Not everyone has the time or resources to have an exhaustive staging environment. Hopefully they have something, but you just never know. But you can be running these kinds of tests in any environment, really. So,
but I think some people we've talked to in the past, Andy, right? They've advocated for chaos in production, right? Which I think
that's going to tell you the most. Yeah.
Yeah, but at the same time, I think even just based on what you're saying with the shift left idea, which I think is very, very sound advice, you probably wouldn't want to encourage people who are just organizations that are just starting to experiment with chaos to start in production, because probably everything will fall apart.
Right? Well, they haven't been thinking about it, right?
Right. So maybe you work out some of the bigger things, and production is for some of the more edge cases. I don't know, but I don't know, Andy or Mandi, if you will have ideas on that, because it would seem like people would be like, yeah, let's do chaos testing and let's start right in production, where everything's going to fall apart if you're not prepared. So maybe don't start in production, I think. But
yeah, your goal is reliability, right?
Yeah.
So we can't tack reliability on at the end of the dev cycle. We know it has to be built in from the very beginning. We have to be thinking about it as we're planning our features. So we want to be able to exercise some of those reliability components as early as possible. So putting some of your chaos testing, your reliability measurements early in your dev cycle is going to help you do that. For folks that are just starting out, I wouldn't want to. That's like going through the data center and pulling cables. You have no idea what's going to happen if you haven't really been thinking about planning intentionally for that kind of reliability. And not everyone does until maybe they've had something happen. It's kind of a response to a catastrophe or a major outage or some other kind of incident. And then somebody freaks out and says, we have to do this now, and tries to jump in with both feet into production.
And isn't that human nature, that you always push things out until actually something terrible happens?
Absolutely.
And you could have avoided it by doing something else, and then hey,
balancing your risk and resources. So.
Exactly. One of the things, and this was in the last recording we had in the last Pure Performance podcast, we also talked a little bit about chaos engineering, but one of the terms we brought up, and this came in yet another podcast with Anna Medina from Gremlin.
Oh, she's great. Yeah,
and she and we came up with a term. It's called test-driven operations, which I thought was actually pretty nice, because if you think about test-driven development, so you write code and you write the tests first to make sure that everything is functionally correct. But test-driven operations is you're actually taking the chaos engineering as an opportunity to validate if your operations works as expected.
Yeah.
So do you get your telemetry? Do you get your alerts? Do the right people get notified? Do you get the root cause information in case you're actually inflicting certain things? And then how fast can people react? So test-driven operations, I thought, was always a really cool term. And I think most of the credit goes to Anna for that term. But what do you think about it? Shall we?
Yeah, I think it's super interesting, right? Because part of it too, are all the things that you've mentioned, plus are the folks who are responding, do they have the right access to solve the problem, right? That can be an issue as well. Do they know how to find the documentation on the service? Is it actually something that's public, or has someone decided to hide it behind some kind of sign-in? and all of those other components that you don't want to be worrying about if you're actually having a real incident or real outage. You want to make sure that that path is as smooth as possible before anything bad happens.
Yeah.
So yeah, love that.
Yeah, you also, I mean, Brian, I don't remember his name, but we had in the very early days of our podcast, and we talked about this, a guy from AWS, and he, I think, brought up the concept of not only bringing chaos to your system, but also bringing chaos to the people. Meaning, for instance, sending people home that are essential, right, to kind of incident response, or taking away their laptops and kind of see how does the organization itself react to an chaotic situation that is then even more chaotic because your key people that you normally rely on are also not there. Because what if you're getting sick, right, and you cannot just call in?
I think that was Brent from the DevOps book, right, the Phoenix Project. Right, wasn't Brent the one that solved everything?
Yeah. I mean, that's something that you have to let people know that's going to happen. Like, that can be really passive aggressive if you haven't warned people that, hey, you know what, we're going to practice this without Mike because Mike's going out on paternity leave at the end of the month. Like, having that kind of talk with your team, that's like, we have this key person, they're only human, so something might happen, and like, you don't really want to get dark with the bus factor things, but like people go on vacation, they have kids, they have other parts of their life, right? So having a plan that says, all right, we've been relying on this person, and part of being a good manager of an operations team is recognizing that that's going on. And if the tooling that you're using isn't telling you that, hey, you know what, this one responder is responding like 80% of your incidents, like maybe you need to sit down and work with your team on broadening that out and skilling up so that, you're not overburdening this one person. That can lead to burnout. They can lead to attrition. All those kinds of things come into it too. But yeah, practicing without the person you always call is definitely a good idea because they've got life.
Yeah. This is a great metric that you just mentioned, the number of responders you have, or who is kind of the top responders. Is this a metric that you keep track of? And then kind of with this, you actually see where your hotspots are?
There's a bunch of telemetry in the PagerDuty platform now that gives you team health and number of incidents out of hours and hours on incidents and all that kind of stuff. So you can start to get a picture for it's the aggregate health of the team, and it's a socio-technical system that is your team and the services that they run together, right? So that you can see, hey, you've got a lot of things that are going on after hours. There's a lot of things that are coming to this one particular responder. There's a lot of escalations into this one person because somebody somewhere feels like they're the only person who knows what's going on here. So it's time to take a look at that. And it's not it has to be intentional. It's not one of those things that will improve passively. It's something that managers need to take on if they have an on-call team that they're responsible for, to sort of take a look at those metrics, pull up the dashboards, and work through what's going on with the team there.
Hey, coming back to the game days, which was one of your key talking points at the conference. I'm sure there's a lot of organizations that come to you, right? Come to PagerDuty or come to you for advice, and they say, "Hey, we've never done this before." What do you typically suggest? What do people start with? Do they run a game day once a year, once a quarter, once a month? What happens in the game day? Can you, especially for the listeners now that are new to this and they would like to start practicing? What are kind of what's the core concept of a game day, and how often do you run it, and who should be involved?
Yeah, that's a lot. Okay.
I know.
So game days are an intentionally scheduled, pre-agreed upon sort of date and time where you are going to inject some kind of fault into the system. And you may know in advance, hey, we're going to test this one particular thing, so we're going to pull out this backend and see what happens. Or it might be more generic. We have this new feature, we're going to test around it and see what happens. But you plan it ahead so that the team knows to be ready, to be looking, to make sure they're seeing the alerts that they need to see. And maybe you have a checklist of alerts that come through and telemetry and monitoring, and make sure all that stuff works, and that's all fine. For teams that are new to it, one of the good things about game days is that they can be very small and contained, or they can be very large. And the sort of the legends, I guess, around the origins of this stuff is like crazy people going through and pulling cables in the data center and good luck, guess what happened, and go from there. But with the modern chaos tooling that you can be very specific about the components that you're going to inject fault into, because you've got little agents that are mostly going to run on your systems and take care of that for you. But you can then be very focused in the game day that you're running. So what I mentioned in my talk is sort of how we do failure Fridays at PagerDuty. And any team can have their own failure Friday. And they may not even run it on a Friday, just depending on what their schedule is. But like one team, if they've shipped a new feature, it's in production, but maybe it's under a dark flag or something like that, and they want to do some testing around it and inject some fault and be very conscious of what's going on there, they can have their own sort of mini game day to practice on, right? And just kind of declare Wednesday at noon Pacific, we're going to be exercising this widget that lives in the ecosystem, and this is what we're going to do. And then they can use that to learn from and improve their reliability. So for folks that are just starting, you can start with a small component. You might start with something that is relatively stable, that you know a lot about. So you can not only practice the practice of game day, but also practice your tooling and make sure that you know the edges and the horizon for what's going on there. But it gives you an anchor to say, well, we understand this particular component really well. We don't really understand our tooling and our workflow yet. So that's the part that we're going to be working on. One of the things that you want to get good at as you practice more game days or these kinds of components is setting your expectations in advance. In some of the chaos engineering literature, you'll see this as hypotheses, right? You're setting a hypothesis. We're going to test this piece of the component, these edge cases, these kinds of behaviors, and be very specific about it so that you're getting the most out of where you think your reliability is stuffed. So I can say, well, I have this one backend dependency that is not as reliable as I'd like it to be. So we've done some defensive coding in our widget. And now our game day, we're going to test that. So we're going to, black hole that dependency, see what gets flexed in our widget, and make sure that the reliability that we wanted out of our stuff is now okay, regardless of what that crazy backend is doing. So even if it goes completely offline, we can still deliver what we need to do. So you can be very detailed and very specific about the things that you want to exercise, the things that you want to learn, and the goals that you're going to set then for the reliability of the components that you're working on. Because they're going to be different. Like distributed systems are wild. So like any given widget might have completely different specs on it and different expectations and different edge cases for reliability. So you can flex all of those things with the modern tooling, which is great, but can be overwhelming, definitely.
Yeah. So Brian and I, we have a big background in performance engineering, load testing, performance testing. I would assume that because you mentioned in the beginning, right, most organizations don't have let's say a production environment where you can just run chaos, or a good sized staging environment that is under load because of some shadow traffic. Does it mean you always have to have at least some type of load testing? And then does this mean you also get in the performance engineers and the site reliability engineers? Because otherwise, if you just pull a cable, simulate a black hole or simulate latency between two components, that's an unrealistic scenario if you don't really have also realistic load on the system itself. So how do you deal from a performance engineer, or like getting actually load on the system? How does this typically work? Do you find organizations that have load tests, or do you then, in preparation of this, actually have to write load tests or also try to generate some load, because otherwise it would be a meaningless test?
Yeah, of all the stuff that we sort of run up against, I think some kind of load generation is probably the thing we're most likely to find in an environment already. Like I think in many cases that's pretty well understood as far as like we need to generate enough load to exercise these components. Where that gets a little bit more sophisticated is, what does that load look like? Is it do your users behave differently if they're logged in versus not logged in? Do you need to simulate that? Is it different if the users are coming in from mobile versus desktop? And do you need to simulate that? And being more specific about that mix versus we're just going to throw an anonymized version of yesterday's load at it or whatever the old school stuff is.
Yeah. So what this tells me, it seems that because we run into quite a lot of organizations that don't have enough load tests, and for me this means like almost a maturity level, right?
It might be.
So that means people only start thinking about chaos engineering if they actually have the basics of performance engineering covered, because otherwise chaos engineering is a too big step and a too far leap to take. So that's great to hear. Now, but you brought up another great use case or a scenario now, because obviously if you have a chaotic situations, your end users will change the behavior.
Yes.
Which means you also need to simulate that type of change behavior, and that again you need to make you need to have hypothesis,
yes.
whatever, you know what I mean.
That word.
And then to also change the load patterns. Yeah, that's really interesting.
Like thundering herd can be a real issue for some environments. Back when I was a sysadmin, like we had globally distributed load balancing, and like if something happened in one pod and it completely fell down, all the traffic moved to the other pods, and then those pods would go down and the original pod would recover and the traffic would swing back, and you could just watch the loops just go and go and go until you like got the whole thing quiesced, and it was just absolutely bonkers. And hopefully nobody has to do that anymore. But
and do you find sorry with Andy's hypotheses,
you got the word right.
That's the plural. Well, that's the plural version of it, I think. His hypothesis. Do you find organizations have the ability, based on watching those experiences in production, to put together good concepts of how users react? Or I would imagine most people have no idea what users are doing when the proverbial poop hits the fan, right? So, and see, Andy, I kept it clean, unlike you. So it just seems like it's a lot of guesswork. Unless, I mean, do you find customers who actually do study that, and how rare is that? Yeah,
they actually do. Like, that hypothesis is a guess, right? Like, that's part of what you're going to discover potentially in some of these instances and some of the things that you're going to be doing. So, especially if you get the opportunity to do some of your chaos testing in production, to be able to say, all right, this is the module that we're currently targeting. We're going to turn it off and see what happens, right? That kind of thing. We'll turn it off for 5 minutes and see what users do. Do they continuously rage click, right? Like, is that what we're looking for? They're reloading frantically to find that thing, or do they not even notice it's not there? Like, those are all the kinds of things that you can sort of pick out from what happens if you have the ability to test these things in production.
It's funny if you mentioned they don't even notice it's not there, because that's a great feature to get rid of then.
Yeah. Well, yeah, that's one of the things you find, right? Like, if you're spending all of your time trying to increase the reliability of this widget that no one uses, you are wasting your resources. So knock it off and put them where the things are that people care about.
Which means you have not the right monitoring in place from the start, because you would already know that nobody's using it, and then you would never have a game day around it.
Right.
Yeah. Hey, quick question. Also, one of the things that I've kept hearing is, they said, well, this is all unrealistic. Nobody would pull cables. Nobody would do X, Y, Z. Right? So my question to you now is, are there unrealistic scenarios that you would not do as a start, because they might really be very, not unrealistic, but maybe uncommon and less probable? Are there certain things you would start with as are there certain chaos scenarios where you say, these are the 2-3 that we always start with because they are the most likely to happen, and therefore you want to make sure that you're testing against those?
I think it depends on the application and like what you know about it already. And in my experience with the things that I've run and the things that I've worked on, like the most common things are going to be unreliable backends. Like, you're going to have something that you depend on, and it either belongs to another vendor, or it's in another data center, or something weird happens, or that team does an update and breaks things. And just the nature of distributed elements in the environment, it's not as reliable as you need it to be. There's other stuff that are things that are easier to do: slow DNS, slow response times from other places, long-running database queries that are really easy to practice with. That are good places to start too. But it depends on the architecture of your environment. If you're using a lot of caching, maybe long-running database queries aren't the biggest deal for you. So it just kind of depends on what's already built into the environment that you're working on. But yeah.
What about like, are there scenarios like disgruntled employee scenarios? Does that come into the play here?
I haven't seen that as something out of the package, but that's kind of interesting.
Because I remember way back, one of the other load testing tools, I don't think it impacted production, but one of the other load testing tools, when a major buyout happened, somebody went and deleted the database of all, the knowledge base, which isn't quite necessarily a production. It's just, data gone in one way. But I don't even know how common it is for disgruntled employees to actually take revenge on systems, because obviously that's going to open them to a lot of legal issues. But yeah, I'm just curious if there's a disgruntled employee scenario in chaos testing, which
not that I've seen. That's super interesting though. But like that's a question for your DR planning, I think, more than your chaos testing.
Well, but that actually would explain the pulling the cables. I mean, that's something where you said, hey, if you say pulling the cables is not realistic, well, if you have a disgruntled employee, then maybe they go crazy and they do something stupid like that.
Maybe. I hope they don't have access to the data center, but who knows?
Yeah. Well, at least it's a fun theme for a game day.
Yeah.
If nothing else.
Corporate espionage.
Yeah. Cool. I really like so these scenarios. Unreliable backend makes a lot of sense. Slow DNS, long-running database queries. I guess this is stuff that you can inflict through latency, right? So there's different tools out there that allow you to increase latency. I guess the black hole example, I think you call it black holing, right? Where you basically say nobody, I cannot connect to that system.
Can't connect to that, yeah.
Yeah. Is this technically, how do you do it? You just configure routing or change? How does this typically work?
Yeah, it depends. Like if you are subscribed to an actual chaos tool, so there's a handful available, and some open source solutions as well. There'll be often an agent that works on the host that will get in the middle of the traffic and either pull the traffic off the wire and dev null it or whatever from that perspective, so that it never gets up the stack into the application and blocks it that way to sort of mimic those behaviors, or puts delays on it, slows it down, that kind of scenario, so that it's you're not actually making live changes to the built environment. You are really just getting in the middle of those inner machine conversations and inflicting the chaos there.
Hey, and how many organizations did you work with then not just using these game days to figure out where the weak spots are and learn on how to manually react to it, but how many are in a state where they already start to test their auto remediation, like really figuring out, hey, we actually have some auto remediation in place, meaning our monitoring detects a problem and is then triggering a script to, fix a certain thing, like redirecting traffic to a different system or something like this. Do you have an idea of how many organizations are that mature to actually have auto remediation scripts in place that they test with this?
It feels like that stuff's really just getting started, or I will say maybe just getting restarted, because those are the kinds of things that kind of have to get rebuilt every time you change an infrastructure paradigm. It's you kind of understood what was going on when we all had virtual machines and powerful load balancers and what happened to had to happen there. And then you have containers and what you can do there, redeploying a container, moving that load around. Now that folks are starting to move more loads into something like Kubernetes, there's another set of solutions that need to get built around those components and what decisions folks want to make about expanding a pod or moving a pod or whatever they're going to do with it. So I think we're kind of in a place where the folks that are leading the charge into Kubernetes are just getting that stuff built. And folks that are in more well understood, or I don't want to use the term legacy or vintage, but more established practices are already well on their way with a lot of that stuff. So it really varies. and it's one of those ironic things where like the old stuff might have the best auto remediation because they know all they have to do is go in and poke that thing and it's fine, versus what kind of sophisticated solution do we want to leverage in our newer environments. So it widely varies for auto remediation around different kinds of infrastructure, and it varies for different kinds of runtimes, because some of them are better at, being restarted and doing a hot restart and those kinds of things too.
Yeah, or systems taking, like, as you mentioned, Kubernetes, right? Kubernetes obviously has some built-in mechanisms already to recycle pods and do things like that. Yeah, I just came off the call, and there the topic auto remediation was also a big thing, and the use cases that they came up with is the classical ones, like cleaning disks, right? Diskful and or database slowness because of reindexes needed and stuff like this.
Oh yeah,
trigger something like that.
The classic things that we've kind of been working on, like they were issues like 15 and 20 years ago, are still kind of under the hood there being issues. So.
Yeah, exactly.
Same thing with those performance patterns, right, Andy? Same old ones in new ways.
It is what it is. Yeah. Hey, now Mandi, let me ask you, kind of getting to the end, but so from your world that you see from a PagerDuty perspective, where people are using your product and your services to really then handle incident response, like you routing the traffic to the right people, right? Obviously, I guess your goal is obviously to reduce MTTR, mean time to respond, mean time to repair. I really like what he said earlier, that you have some statistics or like there's certain metrics in your platform that already give you some indication how you can then kind of plan your game day. Is there anything else that we can learn from especially that part of the of incident response on how to improve system architectures and systems in general? Like, do you see certain patterns in organizations where you say, why are they doing this? I don't know, anything else from the statistics, from the KPIs?
That's kind of an interesting question, because like a lot of it does come down to using your game days to give your folks a place to practice the stressful part of the incident, and like getting to reducing your MTTR in some environments is going to come down to making sure your engineers aren't freaking out, right? And like not being able to think straight. So it's also helping them with being comfortable actually responding to the problem and recognizing that, it's okay, we're going to work through this. We're going to figure out what's going on, make sure that we're looking at the right alerts and they're telling us the right things, and we have the right access, and getting that sort of muscle memory around all of that stuff. And all of that helps improve reliability over time too. Because the worst thing you can end up having there is you've got maybe someone who's new on the team. They don't know where they're looking. They don't know where to find things in either PagerDuty or in your wiki or wherever they are. And they're kind of just lost and staring like deer in headlights. Like, what do I do? And they kind of spin for a few minutes and then escalate. And like, you don't want to get into that kind of cycle. So the whole practice also gives you a way to make sure they know where things are and lower that barrier for them to be able to triage things, to know where the auto remediation scripts even are. Are they attached to the platform? Are they on a Bastion host? Where are they? Like all that kind of practice that comes into it, so that when something does happen, folks are less barrier to success for that whole thing. Because it's a lot of really complex environments out there. And like, you can't just drop someone in the middle and they're going to figure it out. Like, you really have to lead them through a lot of it so that they understand the context.
Yeah. So it's practice is what I hear. Just like
practice.
Just like the volunteering firefighters, right?
Absolutely.
They also,
Just like anything, besides computer performance that come from like a, stage performance, either like plays in high school or music.
Oh yeah.
And it's like you practice and practice and practice. And then when you go on stage for the first time, you're nervous and all that, but after a few times you get used to it. And I remember even a fun short story back when I was in middle school. I think it was 8th grade. We were doing a performance, and the kid, one of the other kid realized he left the prop in the prop room. So we're in front of the stage, in front of the camera, just the two of us. He's like, I know just what we were doing in Oklahoma. And I was, so many things to do in that play with an all-white school. But let's he left the prop in the thing. So he's like, I know just what you need. I'll be right back. And he runs off stage. And suddenly it's me in front of the curtain, in front of the whole, all the parents. And I'm like, crap. And I look at the director and she's like freaking out. So I'm like, all right, I got to do something. So I just start like pretending to talk to myself and complain. But it's like, because I was comfortable enough from that, all those practices, from the dress rehearsals and all, I was like, all right, I got to act here. But to your point, and not to make this about me, because that's what I just did there. The more you go through those game days, the more comfortable you'll be. Yeah. You'll also be able to find, like, is there a focus on people who have a lot of pressure and how you can, like, work with those people? Like, is part of game day identifying the people who panic and figure out some way to work with them to get them over that panic? Because I think some people are just prone to that, right?
Absolutely. And, like, sometimes you might, breathing exercises are a good one, but also, like, recognizing that unless you are actually in a medical environment, like, no one's gonna die. And like part of our incident commander training is taking out some of the external stresses that folks sometimes have about decision making, or do I escalate this, or having like a third party there who's going to help you make those decisions in the incident commander, as well as kicking out people who aren't helpful, like for lack of a better word, right? Like, it doesn't help your responders to have someone there screaming at them to work faster, right? Like, that is counterproductive. So having a practice around focusing on the people who are solving the problem, making sure they have the space to work through the troubleshooting and debugging that they're doing, and, being very predictable about what that workflow is going to look like. And like you bring up, working with plays and stuff. For me, it's marching band, right? Oh, yes. Like, you have marching band, you've got like 150 kids on the field, and everybody's got a different instrument, and there's flags and batons and like crazy stuff flying around. And like, you practice all summer, right? Like, you learn the music. You think at the beginning, like, here's these 12 pieces I have to learn. Oh my gosh, this is crazy. But by the end of August, like, you have most of them memorized. You know your steps. You're on your right foot and your left foot and your turn and all this stuff. And even for like junior high and high school kids, like, it seems crazy when you start out, but like by the end of the football season, you're a pro. So it's the same kind of thing. You want to practice this to the point where like you're a pro, you know what the music is, you know what your steps are, and part of them are going to be in the wiki, part of them in this other platform, and here's how I get to where I need to go. And giving everyone the game days give you the opportunity to say to the newest person on your team, hey man, here's how we learn how to do this. And here's how we count our steps off. And here's how we play our music and get all that stuff going. So
awesome.
Shout out to all the band nerds out there.
Yeah. My wife hates it when I say I wasn't in the marching band. I was in the drum line.
Oh.
Yeah.
I will allow it.
Anyhow.
Hey, Mandi, in conclusio, or kind of like to close it off.
That.
I know, right?
Big word.
Another big word. Hypothesis, conclusio, what else? I learned my Spanish this morning because I'm on Duolingo and I always complete. Silencio, exactly. No, but for kind of closing words, is there kind of to if you want to give one piece of advice for people that are not yet sure, is chaos engineering the right thing for them? Should they do a game day? Give them one last reason to say this is why you want to do it, and maybe just repeat something you've already said. But this is kind of your moment, and say, do it because of this.
Yeah, I mean, you're going to do it because you're going to improve. You want to improve the experience of your product for your users and for your customers. You're after the most reliable system you can build, right? And part of that is trying to get ahead of the bad stuff, the weird stuff that might happen when you get into production.
And with
the internet's the Wild West, there's crazy stuff out there, man.
Yeah. And with this, you not only make your product better and your service better, but also your work-life balance better, I guess.
Absolutely.
Right? Because that's really
absolutely
cool. Hey, I Mandy, we saw each other at DevOps Stage Raleigh. Are any other appearances coming up? Do you have any other conference talks where people can see you?
I will be at GlueCon, which is May 17th, 18th, 19th, I think, right? Then we have PagerDuty Summit, which is 3 hybrid events running in San Francisco, Sydney, and London. I will be in person in San Francisco and London, and those are in June. And yeah, I don't know after that yet. Like August is pretty quiet, so might actually be home. That'll be.
Well, you gotta practice, right?
I know.
There you go.
That's right.
Very cool, Brian. Any final words from you?
No, nothing. I mean, the only other thing I'd add, the only other reason why I'd add to do the chaos to the game days is probably because they're a lot of fun, right? You talk about making your job better, like it's going to be really fun, and you're going to learn. I mean, everything that Mandy said, you're going to get out of it, but you're also going to have fun at work, right? Which is so most people like if you can find ways to make your job fun, go for it, and it's going to have a fantastic payoff for the organization. So if the higher ups are looking, seeing people like doing this crazy thing and having fun, they're like, what's going on? Like, oh, no, look, we're doing something good. Right. So anyhow, Mandy, thank you so much. Andy, did you have any final words or if that's it?
No, for me, that's it. I have some additional great arguments on why chaos engineering, and especially I really like the common scenarios and some of the metrics you told me. I think that's really nice. It helps me in my conversations when people ask me about it. What's the reason for it? What's the benefit? No, that's really. I'm really happy that you were here, and I'm pretty sure this was not the last time we saw each other. Yeah.
We should chaos engineer a recording. I'm kidding. No, please don't. We get that all the time. That was when we were using those other platforms. So anyway, Mandy, thank you so very much for being on today. We really appreciate it, and we love these topics. These are the real fun ones. Even talking about it's fun.
Yeah, it definitely
That's how you
is.
know it would be fun to do. Chaos engineering is just a fun topic to talk about. So thanks to all of our listeners, as always. If you have any comments or questions, pure_DT on Twitter or pureperformance@dynatrace.com. Mandy, I believe you'll probably send us some links on how people can follow and or interact with you on various platforms if you have any.
Yeah, I'm on Twitch as Ellen, or I'm on Twitter now as EllenXCHK. I'm also on Twitch on the PagerDuty channel a couple days a week. So yeah, we're always out there.
We'll include those in the show notes.
Yeah.
And we look forward to good luck with all your travels. And
yeah, thank you.
Hopefully we'll talk to you soon.
All right, guys, take care.
Thank you.
Bye-bye.